Okay, so here's a unit circle filled out for quadrant 1. Okay, so we got a clue? All right, let's go through this. At the end of class, somebody remind me to review this. Okay, so we make sure everybody's on the same page for tomorrow. Okay. Okay. All right, to our notes. Trigonometric functions. All right, we're going to do this two ways. We can do it with the unit circle, which is what we're going to primarily do, but we're also going to do it using right triangle, which is opposite, adjacent, and hypotenuse. Does that sound familiar? It is geometry. It is exactly geometry. You learned that in geometry. Now,
teachers, there will be no JV baseball practice today. Sorry to interrupt your class. No JV baseball practice today.
have y'all heard the acronym SOHCAHTOA?
Yes.
All right, you need to remember and understand that. Okay, so sine is my y, and for the unit circle, my radius is 1 everywhere, because that's the unit, 1 unit. All right, cosine is my x. Tangent is y over x. There are 3 base functions. Now, this is what I call counterintuitive, but sine and cosecant go together. Cosine and secant. The first letters switch. I want them to be the same, so that's why I call it counterintuitive for me. All right, cosecant goes with sine. Sine is y. Cosecant is 1 over y. Secant goes with cosine, it's 1 over x. Cotangent goes with, guess who? Tangent. Yes. Tangent is y over x, so cotangent is x over y. If I have the unit circle, that's how we're going to come up with our 6 trig functions. Okay? If I am not dealing with the unit circle, I'm going to have to use my right triangle information. And sine is from SOHCAHTOA. Sine is opposite over hypotenuse. Cosine, ca, is adjacent over hypotenuse. Please don't go away. Thank you. All right. Tangent is y over x. Remember our ordered pairs cosine, sine, so y over x would be? It's going to be opposite over adjacent. All right. Cosecant is sine flipped, so it's hypotenuse over opposite. Secant is cosine flipped, so it's hypotenuse over adjacent. Cotangent's tangent flipped, so it's adjacent over opposite. Adjacent over opposite. All right, that is as fundamental to what we're doing as learning the first 3 letters of the alphabet to be able to write. You have to be totally fluent with all of that. Okay? Any questions? SOHCAHTOA having to do with math is coming up with angles and sides out of your triangles, and almost every engineering structure is based out of triangles. Trig, trajectory of rockets, trajectory of baseball, if you throw it. All this stuff works off the trig. There's an enormous amount of stuff in the world that's based on trigonometry.
Oh, that makes sense. Yeah, I get it now.
All right.
He didn't know like why,
The acronym.
like, yeah, he didn't understand the acronyms before.
Okay. So sine, let's see if I can do this so that it shows up on the screen for second block. All right. Sine is opposite over hypotenuse. That lets me know what sine is. If I can remember SOHCAHTOA, and I can write it down on the top of my paper, then I know that sine is opposite over hypotenuse, right here. I know that cosine is adjacent over hypotenuse, this guy. And I know that tangent is opposite over adjacent, here. That's what SOHCAHTOA is. It just gives us a set of acronyms that allows us to easily remember what the trig functions actually are coming off of a triangle. Good question. Good question. Okay? Okay. Even and odd functions. We've had these before. An even function. Cosine of negative t will equal the cosine of t. What I'm saying is the cosine of negative pi over 4 equals the cosine of pi over 4. Who goes to cosine? Secant. So the other even one is secant of negative t equals secant of t. Okay? Odd functions. The sine of negative t equals. Think back to odd functions before. What was odd? Even was f of x equals f of negative x. Odd was f of negative x equals negative f of x. So odd function sine of negative t equals negative sine of t. Things like even and odd functions do not go away. We deal with those in calculus. So cosecant of negative t equals negative cosecant t. Tangent, negative t equals negative tangent of t. Cotangent of negative t equals negative cotangent of t. So what I'm saying is if I have the sine of negative pi over 6, it is equal to the negative of the sine of pi over 6. The sine of pi over 6 is 1/2. In quadrant 4 for a negative pi over 6, that would be in quadrant 4. The y is negative, so the sine of negative pi over 6 is negative 1/2. And it is equal to, the sine of pi over 6 is in quadrant 1, is a positive 1/2. And if I take the negative of it, it's a negative 1/2. So the sine of negative pi over 6 is equal to negative of the sine of pi over 6. Even and odd functions. Okay? All right, let's try an example using our right triangles. We want to find the exact value. Now, when it means exact, I want a fraction. Do not want a decimal. Okay? Of the 6 trig functions. All right, so I'm going to want to know what sine of theta equals, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Once I get my first 3, the second 3 are just those flipped. So really it's work to get the first 3 and kind of easy to get the second 3. All right, the way we're going to do this is we're going to graph this. If I'm at the point 4/5, negative 3/5 on my x, I'm going to do, if this is 1, this would be 1/5, 2/5, 3/5, 4/5. So this is 4/5 for my x. Right here. On my y, I need a negative 3/5. So if this is negative 1, it's going to be 1/5, 2/5, negative 3/5, negative 4/5. So my point that I'm given by the ordered pair is 4/5, negative 3/5, right here. Simply plotting that point. Everybody good with that? That then becomes my terminal side of the angle. And we draw a line from the x-axis down to that point, and that makes my right triangle. I have to have a right triangle to be able to use SOHCAHTOA. Okay. What is my y value? What's the length of my y-axis here? That's a negative 3/5. What is my x value? 4/5. Good. What is my hypotenuse? How can I find it? Very good. Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So 4/5 squared plus a negative 3/5 squared equals my hypotenuse squared. What's 4/5 squared? 16 over 25 plus 9 over 25 equals h squared. 25 over 25 equals 1 equals h squared. So h equals 1. But I took the square root. So h equals plus or minus 1, right? Except can't have a negative length for an hypotenuse. It's always positive. So even though mathematically I get a plus or minus 1, we kick out the negative 1 because it makes no sense in this context. Good job. Everybody with me? Okay. Sine is so, ka, toa. Sine is opposite over hypotenuse. And my angle is always at the origin. Do not. No. Do not put your angle down there. It always goes at the origin. No? Good. That was quick. It is. You're close. D and sine, opposite over hypotenuse. What's opposite my angle there at the origin? What's opposite? Negative 3 over 5. Over, what's my hypotenuse? 1. So it's negative 3 over 5. What's my cosine? Adjacent. What's adjacent to my angle? 4 over 5. My hypotenuse is 1. So it's a positive 4 over 5. All right, what's tangent? Opposite over adjacent. So it's a negative 3 over 5 over 4 over 5, which I keep change flip, becomes negative 3 over 4. All right, cosecant. One over negative 3 over 5, which is, in other words, make it easier than that. Flip it. It's negative 5 over 3. All right, when you did the negative 3 over 5, and like you did, it would have, key change flipped, it would come back to the same thing. The easiest thing to do is to literally, what's a negative 3/5 flip? Negative 5/3. Secant goes to cosine. Cosine's 4/5, so secant is 5/4. Cotangent goes with tangent. Tangent's a negative 3/4, so cotangent's a negative 4/3. So you see, if you can get the first 3, you got the second 3. And they literally just flip. All right. All right, we want to find all the points on the unit circle that correspond to the real number t equals negative pi over 3. So on our unit circle, we start here at 0. Now pi over 3, that's not what we're looking for yet, but let's look at pi over 3. That's pi over 3. Which is longer, my x or my y? So the y is bigger than the x. Whenever we have our over 3 over 4s, our numbers are 1/2 square root of 3 over 2. The y is the bigger one of these. So this ordered pair is? Which one's bigger? And the y is the bigger one, right? So which one's the x? The smaller one. Which one's smaller? 1/2, and then y's square root of 3 over 2. All right, that's true for every over 3. So if we come down here and make this a negative pi over 3, my ordered pair, the absolute value of them are going to be the same, 1/2 square root of 3 over 2. But which quadrant's that in? 4. And the fourth quadrant is the x positive or negative. And the y? So it's a positive 1/2 negative square root of 3 over 2.
That's all you have to do, Kelly?
Yes. Okay? Let's do 3. Evaluate the trig function, the sine of 5 pi. Let's draw the angle. Start on the initial side. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. What's my ordered pair here? It's on the x-axis, it's on the left side. -1, 0. Sine of 5 pi is equal to the y value at that point. So what's sine of 5y? 0. Okay? Making sense?
So if we were to do that with cosine, and what is the negative y?
Yes, ma'am. Question was, what if we did that with cosine? So the cosine of 5 pi is my x value, and that is -1. Okay? Okay, let's stop here and let's go back to the unit circle. And let's see if we can go through it, because I think we need to get a better idea of what happens as we go around it. Again, tomorrow, we're only going to do quadrant 1 for the unit circle. All right. Right here, these guys. That's the one closest to the 90 degrees, correct? So it's going to be equivalent to this guy. These two guys are closest to the 90. They're going to have the same things. The one in quadrant 1 is over 3. It's 1 over 3. So this one is going to be 2 pi over 3 radians. The one on the right is 60 degrees. Another 60 degrees is 120 degrees. The ordered pairs are the same except the x is negative because it's in quadrant 2. So it's negative 1/2 square root of 3 over 2. All right, everybody see how to get 2 pi over 3? We've already done the next 45 degree one, which is 135. You go 45 plus 45 is 90, plus 45 is 135. It's an over 4. It's going to be square root of 2 over 2, square root of 2 over 2, and signs depending on which quadrant it's in. It's quadrant 2, so the x is negative. Okay, so this last one, this one that's down closest to the x-axis, it's 30 degrees, then 60, then 90, then 120, then 150, plus another 30 is the 180. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. The ordered pairs are the same except x is negative. Negative square root of 3 over 2, 1/2. All right, we just filled out quadrants 1 and 2. Any questions? Do you see the pattern? All right. First line down, closest to the x-axis. 30, 60, 90, 120, 150, 180, 210. (210 degrees). 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7 pi over 6. These over 6's, every one of them, has square root of 3 over 2 and 1/2, but in quadrant 3 they are both negative. Negative, negative. Okay, we did our over 3. The next one's over. We did our over 6. The next one's over 4. It's the one in the middle. So we'll put this one over 4 radians. But how many fourths is this? Yes. 0, 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 pi over 4 radians. 45 degrees, 90 degrees, 135, 180, 225 degrees. It's an over 4. It's square root of 2 over 2, square root of 2 over 2. Quadrant 3, they're both negative. What's the next one? How many degrees? 240. What's my radians? 4 pi over 3. Good. What's my ordered pair? Negative 1/2, negative square root of 3 over 2. Yes, ma'am. 5 pi over 4. Okay. What happens down at the bottom in degrees? 270. What's that in radians? 3 pi over 2. My ordered pair? 0, negative 1. Alright, see the next line's closest to my y-axis. It's going to be the same kind of stuff as the one to the left. 240 degrees plus 30 was 270, plus 30 is 300 degrees. 4 pi over 3. 5 pi over 3. And positive 1/2, negative square root of 3 over 2. Alright, the next one, my 45s. I did 45, 90, 135, 180, 225, 270, 315. 315 degrees. Radians, pi over 4, 2 pi over 4, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi over 4. Alright, it's a 4 over 4. It's square root of 2 over 2, square root of 2 over 2. It's quadrant 4, so the y is negative. And we have one more. It's going to be over, in radians, it's going to be over 6. How many over 6? Very good. So this is 11 pi over 6. How many degrees? 330. And my ordered pairs are all in the over 6s, square root of 3 over 2. And in this case, because it's quadrant 4, negative 1/2. All right, do you see the pattern for the unit circle? Let's do a real quick trial run. Give me sine pi over 3. Y'all write this down, don't tell me. So give me the sine of pi over 3. Tell me what pi over 4 is in degrees. Cosine of pi over 6, sine of pi over 2, and tell me what 90 degrees is in radians. And that's what the thing we're going to do tomorrow is going to look like, except it's going to be 10 of them. And if Fred comes, he's going to probably ask about maybe writing that part of the unit circle down before we start. What'd you get for sine of pi over 3? All right, so I'm going to go to square root of 3 over, go to pi over 3. Get a highlighter so I can, yeah. Pi over 3 is here. Sine is my y. So it is the square root of 3 over 2. Agreed? What's pi over 4 in degrees? 45 degrees. What's cosine of pi over 6? Square root of 3 over 2. And sine of pi over 2? 1. 90 degrees equals? Pi over 2. Any questions on doing that for anything in quadrant 1 tomorrow? Everybody understand? All right. So, tomorrow, when Fred speaks up, and I give Fred some time, this is what Fred's going to do on top of his paper that I give you. He's going to do quadrant 1, and he's going to make this 0 degrees and 0 radians and make the point 1, 0. He's going to make this 90 degrees and pi over 2, and the ordered pair is 0, 1. It's going to come right in the middle. And he knows that's 45 degrees, it's pi over 2, and my ordered pair is square root of 2 over 2, square root of 2 over 2. He's going to come in between the x-axis and, excuse me, I was wrong. I wrote, I don't know what I said, but pi over 2 is incorrect. It's pi what? Pi over 4. 45 degrees, it's pi over 4. The ordered pair, square root of 2 over 2, square root of 2 over 2. We're going to split halfway between there and the x-axis. Basically, it's slightly less than halfway. And this is going to be 30 degrees, pi over 6. And my ordered pair is, and this is where I could end up trying to get myself into trouble. I need to make sure I get these in the right order. It's going to be 1/2 and square root of 3, but if I come down, who is bigger? My x or my y? The x is bigger. Out of the two numbers, square root of 3 over 2 is larger than 1/2. Then we're going to finish this off by doing my 60 degrees, or my pi over 3, and this has the opposite ordered pair as pi over 6, 1/2 square root of 3 over 2. Once you have that information, you should be able to readily convert any one of the degrees to radians and vice versa, or give me the sine or cosine of any one of those angles, knowing that my x, y ordered pair is in the form cosine, sine. Okay? Okay, so for homework, we're going to do the classwork on quadrant 1 only, including 0 and pi over 2. And then in the book, 4.2 vocab 1 through 3. And let's get a few of these done. 1 through 11 odd. It's not that many. Make sure you can draw the first quadrant unit circle and be able to come up with radians to degrees, degrees to radians, cosine and sine of all those angles. Okay.